Hey everyone, and welcome to another deep dive with us.
Glad to be here.
Today we're going to be talking about microbes
Microbes, yeah,
and climate change.
that's right.
So we've got this really fascinating paper in front of us
Yeah, really interesting.
that argues that scientists are calling for a global response to climate change, and they're saying that this response should be on a scale similar to what we saw with the COVID-19 pandemic.
Yeah, that's right. They're really emphasizing the urgency of the situation.
So we're going to dive deep into this paper and explore how microbes could be a key player
The key player, yeah.
in both mitigating and adapting to climate change.
Absolutely. It's a perspective shift, for sure. We often think of microbes as, the bad guys.
Right.
Agents of disease. But this paper really highlights how crucial they are for regulating our planet's climate.
Okay, I'm intrigued, but help me out here. How did these microscopic organisms factor into something as massive as climate change?
Well, think of it this way. Microbes are like the behind-the-scenes operators of Earth's essential processes. They're constantly producing and consuming greenhouse gases, and they control the flow of carbon through ecosystems.
Yeah.
It's a delicate balance, and climate change is disrupting it in ways we're only just beginning to understand.
The paper uses coral reefs as an example of this disruption, right?
Exactly. Coral reefs depend on a healthy microbiome for survival, just like we humans rely on a balanced gut microbiome. But as ocean temperatures rise, we see more and more coral bleaching, which throws off that delicate balance, and the bad microbes take over,
Right.
and the coral suffers.
So it's not just about rising sea levels, it's about disrupting the very foundation of these ecosystems at a microscopic level.
Precisely. And the ripple effects extend far beyond coral reefs.
Yeah.
These disruptions impact entire ecosystems from forests to oceans, ultimately impacting our own well-being too.
Okay, so microbes are key players in this climate crisis. But this paper isn't all doom and gloom, is it?
Not at all. That's what I find so fascinating about this research. It argues that microbes are not just part of the problem, they could be a crucial part of the solution.
Yeah, and they even lay out specific examples of how we can actually utilize microbes in the fight against climate change. Table 1 in the paper I was really drawn to. It outlines a variety of really innovative approaches. Could you walk us through a few of the highlights?
Sure, let's start with carbon sequestration. Some microbes are incredibly efficient at capturing CO2 from the atmosphere and storing it.
Okay.
Imagine if we could harness that ability to enhance carbon storage in soil and forests, even in the oceans.
But we could have these microscopic helpers working to pull carbon out of the air.
Exactly. It has huge potential.
That's amazing.
And then there's methane oxidation, where certain bacteria actually convert methane, a very potent greenhouse gas, into less harmful compounds.
Wait, so we could potentially turn a climate villain into an ally using bacteria?
Precisely, and this approach could significantly reduce emissions from sources like landfills, livestock, even wetlands.
Wow. What else jumped out at you from Table 1?
Well, there's a lot of buzz around microbial therapies, which involves manipulating microbiomes to restore balance in struggling ecosystems,
Okay.
Like imagine introducing beneficial microbes to help reforest a damaged area or even improve the health of crops and livestock.
So it's like giving a boost to the good guys in the microbial world to help restore these vital ecosystems.
Exactly, and the potential applications are vast, but here's the catch. Despite all this promise, these solutions haven't been widely implemented yet.
Why is that? It seems like we have these incredible tools at our disposal, yet we're not utilizing them. What's holding us back?
It's a complex issue. Part of it is awareness. A lot of people just don't realize the power of the microbial world. And then there's a challenge of scaling up these solutions from the lab to the real world, which takes a lot of funding and critically political will.
Speaking of political will, this paper makes a pretty bold call to action, right? It urges for a global effort on par with the response we saw during the COVID-19 pandemic.
It does. The authors emphasize that we need that same level of urgency and global cooperation if we want to effectively tackle this climate crisis. They propose the creation of a global science-based climate task force.
Okay, a task force sounds like a lot of meetings and bureaucracy. What would this task force actually do?
It would bring together experts from all different fields, scientists, policymakers, industry leaders, everyone working together to accelerate the development and deployment of these microbial solutions.
So breaking down the silos and bringing the best minds together to figure out how to actually make these solutions a reality.
Exactly. The task force would provide guidance to global leaders, secure funding for research and development, and help navigate those regulatory hurdles that often slow down progress.
That makes a lot of sense. But let's dive into the specifics of these solutions before we get ahead of ourselves.
Sounds good to me.
Let's unpack those examples from Table 1 in more detail and see how they could actually play out in the real world.
All right, let's start with those carbon-capturing microbes and see how they might transform our approach to agriculture, forestry, and even ocean management. All right, so let's talk about those carbon-capturing microbes,
Yeah, those are fascinating.
Imagine forests acting like giant carbon sponges, supercharged by these tiny helpers. That's one application we're looking at.
That's a really powerful image. I gotta say, it's hard to grasp the impact these tiny organisms could have.
Right.
Can you break it down for me? Like, how would this work in practice, say, in agriculture?
Well, in agriculture, certain microbes can actually enhance the soil's ability to store carbon,
Okay.
which makes the soil healthier and more productive.
So healthier soil, better crops, and less carbon in the atmosphere.
It's a win-win.
It almost sounds too good to be true. Are there any downsides we need to consider?
That's a really important point. As with any new technology or approach, thorough research and careful implementation are key. We need to fully understand the potential long-term impacts on the ecosystem before we go for widespread adoption.
Right, it's not just about finding solutions, but making sure they're sustainable in the long run.
Exactly.
Okay, so what about forestry? You mentioned that microbes could help us create more resilient forests.
Yeah, trees are already incredible carbon sinks.
Right.
But by introducing microbes that boost carbon sequestration in the surrounding soil,
Okay.
we can actually amplify their effectiveness. This could be huge for reforestation efforts and help protect forests from the impacts of climate change.
So we're using microbes to essentially supercharge nature's own carbon capturing mechanisms.
Yeah.
What about the oceans? The paper mentioned something called marine biosequestration.
Right. The oceans are vast carbon sinks. They absorb a significant amount of the CO2 that we release, and certain types of phytoplankton, which are microscopic algae,
Right.
play a crucial role in this process.
So could we manipulate those phytoplankton populations to actually enhance the ocean's carbon absorbing capabilities?
That's definitely one avenue that researchers are exploring. It could involve fertilizing specific ocean areas with nutrients that promote phytoplankton growth, or even cultivating large-scale seaweed farms, which are highly efficient carbon sinks.
It's fascinating, but also a little bit daunting to think about manipulating these entire marine ecosystems.
Yeah,
Are there risks involved with these approaches?
absolutely. We need to proceed with caution and ensure that we fully understand any potential consequences before we go implementing these solutions on a large scale.
Right. Unintended consequences are definitely something we want to avoid.
Exactly.
Okay, shifting gears a bit, let's talk about methane oxidation. I was really interested in how bacteria can be used to convert methane into less harmful compounds.
Yeah, methane is actually a far more potent greenhouse gas than CO2.
Wow.
So addressing methane emissions is really crucial, and luckily we have these things called methanotrophs.
Okay.
They're bacteria that can naturally oxidize methane, so they essentially convert it into carbon dioxide and water.
It's amazing that these tiny organisms could hold the key to tackling such a powerful greenhouse gas. How would we actually deploy these methanotrophs?
Well, there are a number of potential applications. Landfills are major methane emitters, so introducing methanotrophs there could significantly reduce their impact.
Right.
We could also look at manipulating the gut microbiomes of livestock, especially cattle, to reduce their methane output.
So, potentially tackling methane emissions from both environmental and agricultural sources using bacteria. That's a fascinating multi-pronged approach.
It is, and it really highlights the versatility of microbial solutions.
Yeah.
We could even introduce these methanotrophic bacteria into environments like wetlands and rice paddies, which are natural methane emitters, to lessen their impact.
Okay, last but not least, let's dive into microbial therapies.
Yeah.
This concept of introducing beneficial microbes to struggling ecosystems sounds incredibly promising, but also a little sci-fi. Can you paint a picture of how this might work?
Think of it like giving a boost to the good microbes in an ecosystem, helping it to restore balance and resilience. For example, researchers are experimenting with introducing beneficial microbes to degraded forests,
Right.
which can help promote tree growth and disease resistance.
So it's almost like we're giving a dose of probiotics to the forest.
Yeah, kind of.
What other applications for microbial therapies are being explored?
Agriculture is another key area. By introducing beneficial microbes to the soil, we can improve crop health, reduce reliance on things like chemical fertilizers and pesticides, and just promote more sustainable farming practices overall.
That's a win for everybody, the farmers, the consumers, and the environment.
Yeah.
It seems like microbial therapies hold a lot of promise, but are there any potential drawbacks we should be aware of?
Well, as with any intervention in a complex system, there's always the risk of unintended consequences.
Right.
We need to do our research to ensure that by introducing new microbes, we're not disrupting the existing balance of an ecosystem in unforeseen ways.
That's a point you've raised throughout our discussion, and it really underscores the importance of taking that cautious and informed approach. We've covered so much ground today, exploring all these diverse ways that microbes could be harnessed to combat climate change.
It's a fascinating field.
What strikes me is how these solutions aren't just about, reducing emissions, but also about restoring and protecting the natural world.
Exactly. We're not just fighting against climate change.
Right.
We're working with nature to create a healthier and more resilient planet.
And speaking of working together, let's circle back to that proposal for a global science-based climate task force. What are your thoughts on the feasibility and potential impact of such an initiative? I mean, a global task force, it sounds ambitious, almost daunting. Is it really realistic to think that we can achieve that level of cooperation, especially on a topic as complex as climate change?
It's a huge challenge, no doubt about it. But I think the COVID-19 pandemic really showed us what's possible when we face a global threat. You know, the speed at which scientists were able to collaborate to develop vaccines and treatments, it was really unprecedented. And if we can channel that same urgency and that same spirit of collaboration towards climate change, I'm hopeful that we can make some real progress.
That's a hopeful perspective.
Yeah.
So let's say this task force actually comes together. Where do they even begin? What are the first steps in tackling a challenge as big as climate change using these microbial solutions?
Well, a one-size-fits-all approach isn't going to work here.
Right.
They would need to start by identifying the most promising solutions for different regions and different ecosystems. A solution that works in the Arctic might not be suitable for a tropical rainforest.
Makes sense. So step one is understanding the nuances of each ecosystem and tailoring the solutions accordingly. What comes next?
Well, then the crucial research and development phase would begin. We need to optimize these solutions, make sure that they're safe and effective, and figure out how to scale them up for real-world implementation.
Scaling up seems like a major hurdle. I mean, we can't just have these solutions working in a lab setting. They need to be viable on a much larger scale.
Exactly, and that requires significant financial resources. This task force would need to secure funding from governments, from international organizations, from private investors, and make sure that those funds are strategically allocated to the most impactful projects.
Right, it's not just about throwing money at the problem. It's about investing wisely in the solutions that have the greatest potential. What about the regulatory landscape? I imagine there are a lot of hoops to jump through when you're introducing new technologies, especially when we're talking about a global scale.
Absolutely. Navigating the regulatory landscape would be crucial. This task force would need to work with governments to streamline those regulatory processes while ensuring that things like safety and ethical considerations remain a top priority.
It sounds like a lot of work, but it's also incredibly inspiring to think about the possibilities if we can actually pull this off.
It is. We're talking about harnessing the power of the microbial world to create a healthier and more resilient planet for all of us.
So where do we as individuals fit into all of this? What can we do to contribute to this global effort?
I think it all starts with awareness. Educate yourself about the microbiome and its role in climate change, share what you learn with others, support organizations that are doing research in this field, and most importantly, advocate for change. Let your elected officials know that you care about this issue and that you support investments in these kinds of solutions.
Those are all really tangible action that we can take. It's a good reminder that even those small steps can contribute to something much larger than ourselves.
Exactly. It's about collective action. We all have a role to play in shaping a sustainable future, and I want to leave our listeners with this thought. We've focused a lot on the science, the solutions, the task force. But at the core of it all is this simple, profound truth: we are part of nature. We are not separate from it.
That's a beautiful way to put it. It really reframes our relationship with the natural world and reminds us of how interconnected all living things truly are.
And by recognizing that interconnectedness, by understanding that intricate web of life that sustains us all, I believe we can unlock the solutions we need to address climate change and create a future where humanity and nature can thrive together.
That's a powerful message to carry with us. Thanks for joining us on this incredible deep dive into the world of microbes and their potential in the fight against climate change. Until next time, keep exploring, keep learning, and keep those deep diving minds engaged.